Hey kiddos, we're going to add a new test to your list today. It's called the integral test. There are 3 conditions that you've got to meet before you can even do integral test. The first is that it has to be a positive term series. So you can't be alternating positive, negative, positive, negative. You can be all negative because then you just factor out a negative and surprise, it's not positive. So it just can't be alternating. Also, the terms in your series have to be decreasing, which you're already going to know because the first thing you're going to do is your nth term test where you take a limit real fast. You're going to get 0 and you're going to know nothing. So this is an assumed criteria. I don't know why I said 3. There are 2. Okay, so here's integral test. For integral test of a series, you should take an integral. So we're going to integrate this thing. I'm going to turn my n's into x's because it's not the same thing, and I like writing x's in integrals better. The bounds for my integral are 1 to infinity because those are the bounds of my sum. All right, I don't know what you remember from December. Just kidding. I know that you remember nothing from December. So this is an improper integral. There'll always be improper integrals because you'll always be going to infinity. With an improper integral, we can't treat infinity as a number, so we just sneak up on it, and we go from 1 to t instead. And that's essentially it, friends. I mean, the rest of this is just taking an improper integral, which we've done before. The way these get hard is you don't remember how to take integrals. So this is a u sub so that we can practice u subs again. There is something in here whose derivative is also in here. If u is natural log, then du is 1 over x dx. And now I'm rethinking about my limit as instead of natural log of x, it's now u. And then du has everything else in it because I need a 1 over x, I need a dx, and all of that is inside of du. So this integral is just u squared over 2. So this is like side work, so I don't have to keep writing the limit while I'm doing this because you hate writing limits. So limit, t go big, u squared over 2 is the natural log of x squared over 2, and we're evaluating from 1 to t. So that's the taking of the limit. Now we're going to evaluate the limit. So we are going to plug in top and plug in bottom squared. And now we take a limit. So for this problem, the natural log of 1 is 0. So that's just 0. That's not exciting. The natural log of infinity is going to infinity. Because the integral goes to infinity, the series diverges. If it were to converge, if the limit were to approach a value, then we would say converge. So this one diverges by integral test. All right, when you're running through your options for integral test, when you're running through your options for determining whether a series converges or diverges, I imagine integral test is going to be pretty low on your list because you don't like taking integrals. So why would you choose integral test if something else works instead? So we're going to put in here integral test. We're going to say that it has to be positive term series only. We're going to say that the terms have to be decreasing. And then for it to converge, so if we have the sum of a sub n, we're taking the integral of a sub x dx from, and I'm going to go ahead and write the limit because it's always going to be there. And that's going to approach some number. 0 is a number. As long as it's not infinity or negative infinity, you're good. And then on this side, I will write the same limit and integral. That's a t. Oh, I didn't put a t over here. A sub x dx, and this one approaches plus or minus infinity. All right, that was quick. Let me know if you need anything.